of mean motion. In this photograph, we can compare mean laminar and turbulent profiles. Here is the laminar one, the turbulent one, and here they are superimposed. The velocity gradient normal to the plate is larger for the turbulent layer, and it therefore has a larger wall shear stress or drag. The circulation is the same for both layers. Both boundary layers therefore contain the same amount of vorticity per unit length of the plate. However, the distribution of vorticity in the two layers is very different. There is more vorticity near the plate in the turbulent layer. The distribution of momentum in the two layers is also different. In the turbulent layer, high momentum fluid is moved toward the plate, and low momentum fluid is moved away from the plate by unsteady, random motions. There are larger shear stresses and more momentum in the turbulent boundary layer than in the laminar layer, and the turbulent boundary layer is slightly thicker. In the diffuser, the turbulent boundary layer along the bottom wall does not separate, while the laminar one does, because the three-dimensional interchange between regions of high and low momentum fluid in the turbulent layer is more effective than the molecular diffusion in the laminar layer. Similarly, a turbulent boundary layer on the upper surface of this airfoil prevents large-scale separation, or stall, until a very high angle of attack. The blades along this wing are called vortex generators. They introduce axial vorticity, which enhances the naturally occurring rotary momentum interchange in the already turbulent boundary layer. Such mixing delays or prevents separation. In this film, we looked at flow along a flat plate and then saw the effect of pressure gradients on boundary layer flow. Now we can understand how this cylinder influences the flow on this plate. Without the plate attached, there is a static pressure increase along the stagnation streamline, with a corresponding decrease in velocity. When the plate is attached, a positive pressure gradient is imposed along the plate in the flow direction. This unfavorable pressure gradient causes boundary layer separation, and the flow field is radically altered.